And now we're going to graph sine and cosine graphs that have all the transformations mixed into one. And instead of using what we did in our transformations unit, which was taking points and going from left to right, doing your stretches and compressions first, and then your translations, and that would still work, but it would take a little bit longer, because with your sine and cosine graph, you have 5 key points, from the middle to the maximum, to middle to the minimum, to the middle again. And so we're going to see, can we create a faster way using what we noticed with amplitude and center line and period to graph this quicker. So we're going to call this graphing as our title. Y equals A sine B x minus c plus d, and y equals A cos B x minus c plus d. Again, you can put an extra set of brackets around this if you'd like, to show that that's what's inside our function. That's all of our horizontal things. And again, unlike before where we did our transformations from left to right, we are going to look at a special order for graphing sine and cosine, which will make it quicker for us. And in that special order, we start with the exact opposite thing that we would start with before. And we have an acronym for remembering this special order. We're going to call it DAB-C. We are going to start with our d value, because no matter what the transformations that happen, the d value will always be your center line or sinusoidal axis. So we'll label it with a dotted line. We'll then look at our amplitude. We'll use our amplitude and the center line to label the max and minimum values. So you'll be able to see the range right away. We'll use the b value to find the period. And remember, I'll just write the formula here, that your period is 2 pi over the b value. Whatever your period is, you're going to take that period and divide it into 4 equal sections. The next thing you're going to do is you're going to graph it without the phase shift So I have a bunch of dotted lines here. We're going to graph it without a phase shift with a dotted line. because it will help us see how to graph it in the end. So in the DAB-C, the dash that's in the DAB-C is telling you this step in green. And then finally with DAB-C, we can apply the horizontal translation. Whew. Okay, now we're going to write down those instructions. We'll do an example at the bottom, and then we'll do some examples in our notes, and all of these instructions will become clear. Sometimes we write things down and it's sort of like, I don't quite understand this yet. We'll do some examples. They'll help you see it. So at the bottom of page 351, we'll do an example. Okay, we'll graph y equals 3 cos cos 2x minus pi over 4 minus 2. And we're going to graph this using DAB-C. Was everybody done writing down the instructions? Yeah? Okay. So, here's our axes. Going through DAB-C means start with your D value. Your D value here is minus 2. Minus 2 will be your center line. So the first thing you do is you go to minus 2, take out a red pen if you have it, draw a dotted line, label it at y equals minus 2. That will be your center line. The D part is completed. Next part in DAB-C is your A value. Your A value is your amplitude. Your amplitude is always the distance from your center line to a maximum and center line to a minimum. So the next thing we're going to label is what our maximum value is and what our minimum value is. So I go from my center line and I'm going to go up 3. 1, 2, 3. That's a bad looking one. There we go. That's a nicer looking one. 1 is going to be my maximum. And if I go down 3 from my center line, negative 5 is going to be my minimum. We have now done the A value. The A value in DAB-C helps us find our maximum and our minimum. And it uses the amplitude and the center line to do that. Next, our B value, which is 2, our B value is going to figure out our period. So off to the side here, I know that my period is 2 pi over my B value, so my period is going to be pi. So I go on my x-axis, I mark pi, and I divide it into 4 equal sections. 1, half of that, and label them. So half of pi would be pi over 2. Half of pi over 2 would be pi over 4. 1 pi over 4, 2 pi over 4. This will be 3 pi over 4. So we have now done the B part of DAB-C. The dash means temporarily draw your graph without the phase shift. This is a cos graph. Where does a cos graph start? A cos graph starts at a maximum. So I'm going to, with the dotted line, temporarily draw the cos graph without a phase shift. starting at my maximum, then going to my center line, then to my minimum, back to my center line, and back to my maximum. So you can see that your maximum and minimum values come into play, and each of our 4 sections come into play, and our center line comes into play. So we can temporarily, again, this is not our final graph, so I'm just drawing it with a dotted line. This would be the graph before the phase shift. And finally, so we have now done the dash part. Finally, the C value says apply the phase shift, so we need to move everything pi over 4 to the right. So looking at your 5 key points, I'm going to take this one and shift it pi over 4 to the right. I'm going to take this one and shift it pi over 4 to the right, pi over 4 to the right, pi over 4 to the right, and shift that one pi over 4 to the right. And now I can draw my final graph through all of those points. And there we have the whole graph all at once. So this is a lot nicer than taking those 5 points and doing the transformations with them. This will be quicker, but it still has quite a few things involved. So if we look at example 1. Okay. In the part here, predicting the graph, just a description of what each of the things are, starting with this 1/4. This 1/4 is a vertical compression. You would multiply all your y values by 1/4. It's also the amplitude. The 3, that would be a horizontal compression. You would multiply all your x values by 1/3. That 1/3 then is going to affect your period. The pi over 6 would be a horizontal translation, pi over 6 to the left. And finally, the +2 is a vertical translation to up, and that will be your center line or sinusoidal axis. Just like our transformations unit, in order for us to do all of this, we note here that we have a horizontal compression and a horizontal translation, but can you see that it's already in the factored form? Sometimes it won't be in the factored form, and that special note that we saw in Chapter 3 would come into play. In this case, it is already in the factored form. So now part B, we're going to graph this. Okay? We're going to graph 1 period, and then we're going to see what does it mean to graph it from -2 pi to 2 pi. So I'm going to actually graph this twice. I'm going to graph it once as if it just said graph at least 1 period and how you would go about doing that. And then I'm going to graph it again with the domain that this question says, graph it completely from -2 pi to 2 pi and what that would look like. So normally we just have to graph at least 1 period. If you're doing that, again, you're going to think about the technique of DAB-C. When drawing my axes here, I'm going to draw it so that it's a little bit lower because I can already see that my center line is at 2. So I'm going to draw a dotted line at 2, label it y equals 2. That's my center line. My amplitude is 1/4. So on the A part, you use your amplitude and the center line to mark your maximum and your minimum. So my maximum will be 2.25. My minimum down a quarter will be 1.75. So this is going to be a very skinny graph because it has a very small amplitude. Next, our b value helps us find our period. Our period is 2 pi divided by the b value, and since the b value is 3, our period will be 2 pi over 3. You go along your x-axis, take an arbitrary spot, and mark 1 period. Then divide that into 4 equal sections. Half of 2 pi over 3 would be pi over 3. Half of pi over 3 would be pi over 6. The third one here would be 1, 2, 3 pi over 6. 3 pi over 6 simplifies to pi over 2. So those are our 4 sections. After doing the d, the a, and the b value, the dash means draw it temporarily with a dotted line. This is a cos graph. A cos graph starts at a maximum. So we'd start at a maximum. At our first part, we would be back to the center line. At our next ticking mark, we'd be at our minimum, then back to our center line, then back to our maximum. This is the temporary graph. And now we need to shift it pi over 6 to the left. So the last thing we do is the phase shift. We take our green dotted line here. We're going to move everything pi over 6 to the left. So I'm going to label here, this is negative pi over 6. That's moving it to the left. And this point, that's my maximum. Now we'll move here. This point, pi over 6 to the left, pi over 6 to the left, pi over 6 to the left, pi over 6 to the left. And this is my final graph if I had to graph at least one period. The next thing we're going to do is we're going to graph it from negative 2 pi to 2 pi to see what it looks like if we do exactly what the question was asking and graph it over a specific domain. But before we do that, any questions about the DAB C in the order that we did it? I'm going to split this perfectly in half. I'm going to mark 2 pi here and negative 2 pi there. And I'm going to try and transfer everything that we had on our first graph over to this new scale. So we still have our center line at 2. We still have an amplitude of 1/4, so our maximum value will still be 2.25, and our minimum value will be 1.75. What gets a little bit tricky here is trying to split things up according to the scale that we have. So thinking about my original graph, I need to have these things measured on my graph, which have scale marks of pi over 6. How do I go about doing that? Well, 2 pi over 3 is 2 pi separated into a third. So I'm going to look from 0 to 2 pi, and I'm going to sort of separate it into thirds, and I'm going to label this as 2 pi over 3. Similarly, on this side, can you see that you would have negative 2 pi over 3, and I'll label that third there as well. If this is 2 pi over 3, does this make sense that this would be 2 pi over 3s or 4 pi over 3? And this would be negative 4 pi over 3. I'm going to switch colors here on my x-axis, and above I took that 2 pi over 3 and I split it into 4 equal sections. So I'm going to split this into 4 equal sections, this part into 4 equal sections, this part into 4 equal sections. Same thing on my negative values. I'm not going to label them all, but I am going to label this one as negative pi over 6. That one's important because we did a phase shift of pi over 6 to the left. Now all of those marks on there, they represent the same marks that we had here. If I just replicate what I have in the graph above, we had at negative pi over 6 a maximum, then center line, then minimum, then center line, then maximum. Those are the points that we had from our graph above. And so what you need to do with this bigger scale is keep this pattern going. So I was at a maximum. At the next ticky mark, I'll be back at the center line, then at the minimum, then at the center line, then at the maximum, then at the center line, then at the minimum, center line, maximum, center line. And keep going in the backwards direction as well. And it's just kind of annoying. Did I miss one? Am I lined up? Whoa, yeah, I'm not lined up. There we go. And then play connect the dot and have fun drawing your curve all the way through those points. And that would be the graph between negative 2 pi and 2 pi. It's tedious because we have so many periods that we needed to draw to go all the way through. So you'll find your textbook sometimes does this. An exam won't. An exam will ask you to draw at least one period. So that's where this graph that I have above is more in line with your exam, because you can draw one period, put the arrows, and say it continues on forever. But that being said, we should be able to graph it over any domain we wanted. So we took what we had in our graph above and we extended it from negative 2 pi to 2 pi. So our first graph just looked at this little section from 0 to 2 pi over 3. We had to extend that. So we had to think about, well, 2 pi over 3 is a third of 2 pi. And this really shows the horizontal compression that's happened in this graph. Okay, we need to practice graphing. So here you go, 3, 8, 9, 10, and 11.